Hello and welcome back to another episode of serde-yaml. It's Byron speaking. In the previous session, we have finished our first PR that was all about setting up a usable test suite that allows us to grow in complexity without losing track of what we want to do. So what we have here is a first test that tries to serialize a simple data structure, which actually looks like this, or should look like this, if it's serialized to YAML. Right now, I think that's not actually happening right now. If you run cargo test here, it looks more like that. So that's basically just JSON output, right? Because our serializer started off as JSON. Because it's very familiar, or it's very, JSON is a subset of YAML. So this would be valid YAML, but obviously we want to be more on the YAML side of life. So no commas here, and this outside braces should be gone as well. So I have no idea how to do this, but this is, something we try to get to work now, so that ideally the strings match exactly. And as we deal with structures most of the time, the order matters to us. So order is undefined when it comes to the YAML standard, just because dics by default, or hash maps, they don't have a predefined order. But we will have an ordering. So this is fortunately maintained as well using our Python script here that generates the serialization data. Okay, so something I would want to do is to have a look at our structs fixed rs, which contains this data structure here. Structs in just contains the structure as we define it with the derive statements here. But this is processed, and then the fixed rs is generated that contains not only the data structure, but also the implementation of serialization and deserialization. And for now, we are only interested in the serialize implementation here. And this is where it gets interesting. Okay, how does it work? Probably now's the point in time when I should look at the documentation here that is provided under making a type serializable without macros. Under the cover, serde extensively uses the visitor pattern to thread state between the serializer and serialize, without the two having specific information about each other's concrete type. This has many of the same benefits as frameworks that use runtime type information without the overhead. Yeah, because the code that is there is kind of very specific to the actual structure. In fact, when compiling with optimization, Rust is able to remove most or all the visitor state and generate codes that's nearly as fast as handwritten serializer format for a specific type. That's very interesting. Didn't know that. If you look at the code here, you would hardly believe this can be optimized so easily, but apparently it can. So how does it look like? So this is part of the serialize trait, which gets a serializer and returns a result, and possibly an error here. A serializer error, okay, which is also defined by the serializer itself, where this is just a serde serializer, okay. And then all this stuff is internal to the function. Wait, so that's the brace for the function here, and now we are inside of the function. So we have a visitor. And that's all. This, by the way, is code that I have no influence on. So I just want to see how the call works. I just want to get an idea. So we have an internal data structure that also that implements the serde map visitor, and this will then do what it does. It should, let's have a look at the calls here. Visit. So it implements the map visitor visit. I think I might want to have the documentation of serd on screen as well. I mean, not only this one, but also that one. So serializer, right? So this is where visit is called on all the time. Wait. Yeah, apparently, so serialize, this is what we implement on the respective type, on the respective data type. And it comes pre-implemented for plenty of standard data types already. So I think that implementation is used then when serializing the fields respectively. And yeah, this really all here. That's it. Just a serialize function. So on the serializer, yeah, actually I could just click here. Huh? We then call the visit functions, and apparently visit itself doesn't even exist here. There's just something. Oh, that's the map visitor. So maybe there exists some visit function, plain visit function. Okay, here's the map visitor. Okay, here's the visit thing that we want to implement. So, and the data, what's this? Okay, that's the value. It's a borrow. It keeps a borrow of the data respectively. Interesting. Gee, why does it need this internal thing? Can't it just keep the state on the stack without this thing? Maybe it has an advantage that I don't yet understand. Anyway, shouldn't matter to us. So basically, each time we call visit, we advance our state and thus get into a different match case every time. And yeah, this is always 9, is preset. Visit named map, serializer visit named map, and then we just, this is why you need this visitor. This is why you need this type here, just a structure that implements the respective data type, or the respective map visitor that we need. And this is how that works. So visit, where is it? Visit named map, right? And this guy takes a map visitor, and then I think the implementation will just call repeatedly until it has visited all the 9 fields. And this is how that works, I guess. And try visit map element. Oh, look at that. This is a dot here. This is a call on the serializer. So I guess in the moment, yeah, where's the so let's have a look. Where's the implementation? Visit enum unit, visit sequence with the visit map, visit named map, visit map element. Okay, so far so good. Is there a visit named map here? No, it's not overridden. So that's default implemented. I guess I want to see these default implementations here. So let's bring in another folder here. This is serd.rs, serd, right? Sidebar. Let's have a look. Yeah, so at some point this JSON obviously will disappear. It will be in its own project. That's fine. It will be difficult for everyone currently using serd because serd comes with JSON. And if this should really move out, then people will have to change their cargo toml files. But that's okay. We are pre-alpha, or we are basically in alpha mode, so we can change whatever we like to change. And I kind of have 30 minutes left before I want to go to lunch. So let's try to speed this up, shall we? So it's going to be a 40-minute session only this time. Okay, we have serd. Is it here? Impulse. Where is the named map? Not here. Here it is. Ah, so just calls visit map. Interesting. And visit map. It's interesting. The name is not used at all here. Maybe visit. Yeah, I don't know. It apparently is also not used for. Yeah, named map we don't have. Visit map we do have. And the map visitor, it doesn't. Yeah. Match lang. So if we have a length. And it's 0, then we just give it empty parenthesis. I think we do this for YAML as well. And here we start now. And while there's something to visit, okay, that's just iterating basically over everything, I see. And this open and close, this is something we should only do if this is the first, or if this is the top level map here. And I wonder how we can know that it's a top level thing. Maybe we don't know. Maybe just say, okay, we have an indentation level and we increment this. But how does the indentation stuff work here? Indentation and the pretty printer thing. How does it work? Escape string. Yeah, we have to review all of this. And the inline stuff, I don't know if I should force it to be inline or not. No idea. What's good or bad probably causes a lot of code to be generated. And I'd rather not force him to do this, but yeah. It's none of my, that's optimization, that's none of my concern right now. Creates a new YAML serializer. Compact formatter. Okay. Where is that even coming from? Here it's coming from. So how does that work? Formatter for oh, it's coming with its own trait here, and it's public even. Interesting. So it opens with a particular character. Does it write all what you want to have for a single character? Probably. But that's kind of costly, I'm saying. But anyway, must have its reason. I know if you use just write, it might actually fail, and then you have to do the looping yourself and the handling of errors. Oh man, pretty formatter here. That's with indent. So, current indent, comma, colon. So this is how this indentation stuff works. It's interesting. So the pretty formatter is the one we use right now. And this is where we would have to kind of integrate. I mean, YAML by default, it needs white space. So even the compact formatter should have a notion of this. So if you don't use toPretty string here, but instead to string, then this is actually what should come out of there, right? That's the default. So that's more close to what we actually want to see. Oh yeah, toString doesn't yet exist because librs doesn't yet export it. toString, I think it does exist. Yeah. So see, this is something that shouldn't come out of there. But it's interesting because now we can probably figure out how this is supposed to look like. Colin comma. So the formatter, how does it work? Okay, so only specific functions are used, and the formatter is the one that allows us to implement variations on the formatting style. Yeah, I get that, but I would still be wondering how this has to be working for us. I think this is all stuff that we could possibly keep. to write a pretty. And all these utility functions here, it's also something I might run and rethink. But who knows? I don't know what the style should be, but that's also something I should think about when it's time. So that writes a current ident, self ident. So that's the indentation level, and that's the indentation character, huh? Yeah. And default indentation is 2. So yeah, that would totally work for me. And I'm thinking, why should I not have one formatter that takes a bunch of options that does the right thing? Because right now we kind of have some sort of pretty formatting going on all the time. So we have a standard YAML formatter, so I might want to put them together maybe. Let's do this. So toString pretty, I would remove without... I would just remove this. This width formatter is something we want to keep, obviously. New, and where's the width formatter? This is how pretty is attached to all string formatter, or to all serializers that have a pretty formatter in there. So that's something I would kick. The serializer with formatter, something I would want. And that's interesting that in this case, the compact formatter is just does not need to be specified here. Yeah, I wonder if I can put these together. I wonder. Yeah, anyway, that's supposed to be the formatter. That's all gonna stay into inner. Returns the writer and consumes itself. That's also cool. I think that's also not part of the trait. It's kind of just something you can do. In this case, this is implementing the trait. All right. We have an IO error as the only kind of error we know, which seems all right as well. And the point is that I do not want a compact formatter. I think the compact formatter, I'm just going to toss it away. And use a pretty formatter instead that I shall rename to standard formatter or something. Yeah, so we won't get too far in this session, I think, considering that there are only 20 minutes left of it, even less. So the standard formatter is supposed to be the default one. Like this. And can it be initialized with just, I think you'd want standard formatter new, huh? That's the default one. Yeah. And then I would have something like with options later. To allow what to do explicitly. Because there are many possible ways to serialize such a YAML structure, kind of how human readable it should be. We should get to a point where we can say, well, it's supposed to be YAML, JSON style, and then the YAML that it outputs looks like JSON, which is valid YAML, you know, but that's something we should be able to support using the standard formatter. And eventually, once this works in the most general case, we can consider having a more optimized formatter that will only support a certain style, but allows for no configuration here. So that's something we could want to have. Yeah, the cool thing is that this trait here that is used, this formatter trait, is just internal. So we don't care. We can change it the way we want it to be changed. ToString pretty is something we don't even have anymore. Yeah, so ToString is going to be what we have. ToString pretty. Oh, look, it says to vec pretty and then from UDF8. Interesting. So all this pretty stuff, I guess, has to go away. To writer pretty, because we don't have that anymore. Serializer pretty with a writer. Serializer new with a writer that comes with a with a standard formatter new, and yeah, from there we can go ahead to vec. As uses to writer, so it goes down to 2 writers. So all we have to do for now is to get rid of the pretty stuff. ToString pretty. Okay, that goes away. Cool. And yeah, we should still compile, should we? Simplification, that's the start of it. Yeah, all this inline stuff, I'm not sure about it, but we will take care of that later. Oh, expected 1. What does it standard? Oh, it needs A. For the lifetime of a borrowed string. I don't like that. I would rather have it keep a standard string. But, you know, or something that supports asref SDR. That's something we could consider. But then we have a type parameter, which kind of trickles down to everything possibly. So I'm a bit, yeah. So let's just use this then. So it doesn't, yeah, see now I also need -a here, and I do hope that it doesn't force me to edit anywhere else, man. Will you be happy? Nope. See, now it trickles through. Shit. I hate that. I downright hate that. So yeah, sure, I now need this everywhere. Just because of the default here. Can we also say that this default is not set? Let's not set a default. Why should we? Let's try that. Maybe that works. Wrong number of type arguments. Expected 2, found 1. 17. Ah, that's the one. So now I think it's time to put that guy. Yeah, all this inline, you know, I think the optimizer should decide that. I'm not going to make all this inline. I'm already against that because that generates just a huge amount of code. Expected F found a standard formatter. Interesting. So apparently, in the moment you have a default argument. Yeah, I'm not sure about that actually. So where are we? We are on 24. Ah, because we didn't specify this stuff here. Yeah, so we might have to go ahead now and put this here. I like that style. Oops. Looks good. Let's do it like that. That actually looks quite good. I also like it like this, but this looks better. Amazing. So yeah, possibly we have to specify it like that, even though we might get away without the writer thing. Expected F. Serializer with formatter. What's your problem now? Expected type parameter. Found struct standard formatter. Really? Expected a type parameter? How do you expect? So it's only for the new, right? It's only for 26. Does it make any difference? Probably not, no. That's good. Maybe this doesn't make any difference. Let's kick it. Yeah, it doesn't make any difference. So once a type parameter for some reason, serializer with formatter. So that guy is being called. But that makes no sense. Shouldn't expect a type parameter here. Why? Interesting. So maybe this is why this one had to move elsewhere. This is why. That's interesting, man. It's very interesting. So cargo build will just provide this one error here, and we can focus on what's important. Interesting. I rarely see this. Actually, that's the first time. I wonder why I can't call with formatter here and just provided a formatter that has the correct type. maybe because it really wants to have this special implementation that says, well, oh man, it wants to have it like it was before. Interesting. So where is that again? Yeah, so this was just containing the W here. And the formatter was preset. Interesting. Yeah, so the reason why I removed this is to get rid of the requirement for the type. But maybe a mix of both could be possible. Can I undo to the point where I get this back? Yes. So what about, and let's try that again. So that doesn't work, or it does work? Expected 2, found 1. Because it's not default implemented anymore. But if I would now add this, So, oh yeah, so I guess I have to put the type that I will provide here right away, right? So can I now let type inference play a game here? Use of undeclared lifetime name. No, that doesn't work. That's set. Can I work without a lifetime? Probably not. That's interesting. First time I run into this. Yeah, so it wants the lifetime parameter. Well, then here you have your A. I shall just edit to this particular implementation. Maybe that works then. Yay, that works. Cool. Nice, nice. I like. Good. I understand now, I guess. So in the moment, not everything is, or not all the type parameters are actually used. I have to add the explicit signature here. And I wonder, does type inference work here? Can I just say, well, figure it out yourself, dude, you're smart. No. And types on item signatures. Sad. Yeah, it would have been cool. But anyway, we should be fine with that. Let's see what the test says. Now we should get some sort of pretty printing. So we are back where we were, but we have kind of removed the pretty printing stuff and replaced it with one formatter that can do everything at some point. It will receive options that we will use to specify how that should look like. And here I would go ahead and do it right away with options, right? And this is just an option, standard formatter options or something. Pub struct standard formatter options. So current indent is something that belongs to our current state. We'll keep that. But the indent is something we want to use. Yeah, I guess if I keep going with that, I will have to do that. With the lifetime parameter as well. So that's an indentation string that we will repeat as often as necessary to make happen. I like that style, standard formatter options. So here we will just keep the options instead, which also means that we do not need a lifetime parameter here anymore. Yay! Awesome. That's nice. So that simplifies that thing quite a bit. Cool. If you want to get rid of lifetimes, move the lifetimes in a separate, or all the members with a lifetime parameter in a separate struct, and then own it. That will fix it. So that shall be with options. and this is with options. Yeah, I shall implement default. Impl default for standard options. Fn default return standard formatter options. Seems like a lot of repetition here, huh? But that's how it is. It makes sense. Would be cool if I could say self here, and I think that even works. Then I don't have to repeat it just one time. So indent, the default indent is supposed to be 1, 2 spaces, and we are done. So that's default. This is this with options. We could actually say default. This will now work. And here we say with options and take options, which are something we want to own. Standard options, current indent, opts is options. And that is that. So now we are set up to basically do everything we want to do ever. Standard formatter options. So now wherever we use the indent, we want to go, oh yeah, by the way, this is public. People can just initialize this structure as they like right now. I don't see a problem with that because that should be sufficiently simple. Otherwise you might panic or something. I don't know. You'll see about that. But for now, I think pub is okay for now. So yeah, let's just find and replace. Just 2 spots. Good. So that's now self opts indent. Good. Thanks for this. And we should be fine here. That should still be the same. Should still be totally the same. Except for the fact that we currently do not support a to-writer options method that we might want to add here. And these are just convenience methods after all. Yeah, but I might, you can create this manually yourself. You can have a new serializer that takes a writer, and the serializer new, you can say serializer with options. And basically this part is the stuff that you can do yourself. And we'll see about that. So for now, to string, let's have to writer. And anything else? No. To vec. I'm not so sure about this. To vec takes a vec with capacity. Oh, vec implements write? That's interesting. I didn't know that. I always used a cursor for this. Vec implements write? Honestly? That's awesome. I didn't know that. Probably vec u8 implements write or something, huh? Show me. It implements write. Rec u8 implements write. Awesome. Oh my god. There I see some potential for improvements, because right now in my test cases for the JSON tools, I think I use a cursor all the time. Where are the tests? I think where's the cursor? So here I don't. Oh, probably I don't, because this doesn't work on doesn't work with IO. Here is a cursor. Okay. Yeah, I'm not sure. Destination. Look, actually this could be a vector. But yeah, and this also works with bytes. That could work. Anyway, it doesn't matter really. Not for us. And time is up as well. So let's just say, yeah, it should work. Standard, it's 17. True, these go away now. And this makes that go away. Simplification. Appreciated, wrong number of lifetime arguments. Expected 1. Oh, true. 275. Let's fix this up quickly. Impl A for A. And this should be fine. And that's that. Soon. 285. Ah, damn it. And this is where this is where this comes back in. Man, I hate these. I hate them. Now I have to add them back. Expected 1, found 0. That's why we've just removed that. Yeah, well, honestly, this is so annoying. If they would remove this, I would be so happy. This can be inferred. This can be, or elided or something. Type elision, something. 288. Standard formatter. And soon, cannot infer an appropriate lifetime for lifetime parameter A due to conflicting requirements. With options, okay, standard formatter A. Like this, huh? Happy now? Yes. It's happy now, we still get the same thing, but we improved it a bit. I think it's refactor. Refactor, sir, removed. Deal with standard for matter only. The compact formatter shouldn't play a role for standard YAML as white space matters, thus making the standard more like what is currently the pretty formatter. Yeah. The standard formatter supports an option structure which should allow to specify everything we ever need to define, we ever need when serializing data. One day we might implement specialized formatters which could be faster for certain common applications, which I don't yet know. So that is really something we might or might not have eventually. Cool. Yeah, right now this doesn't work, so skip CI right away. Tests still fail locally, so no need to think it could work publicly. So if I push this now, I can start setting up a PR, which is the next one we will deal with eventually. Serialization of simple values, that's 3. And I think we do a PR. Yeah. Let's get mine. GitHub. YAML. Where's Byron YAML? Huh. Well, that didn't really work. YAML. Repositories. Oh my god. So I guess I wanna go here. Repositories, YAML. And then set up that pull request. Which is this work in progress. Implements 3. And yeah, I'm not sure. Can I? Oh, I'm in serde-yaml. Cool. So I can, because I have the permissions to do that, right away assign it the respective milestone and go ahead. That's nice. So here's the link. Now this PR is linked to the respective issue. And I don't like it because it's kind of duplication of stuff, but I want to try this PR-based workflow anyway, because that will definitely help to receive comments on the changes. That is the whole idea of it, right? Because if you don't have a PR, commenting on individual commits is a bit cumbersome. So that's kind of the way you want to go ahead with this, I think. That's nice. So PR is there. I think we are, time is up as well. So we are good. We still have to implement the actual stuff. I will think about it during lunch and be back. Oh, what happened here? Did I not save this? And be back soon.